This webinar goes over basic soundcheck sequence writing. We'll talk about how to take those steps and put them into a sequence. Finally, we'll go over a real-world example sequence of how to test for a specific device. Alright, so we went over really basic building blocks used for creating a sequence in soundcheck. We've talked about how to define the waveform, how to apply it, and how to compare them, and some kind of different options for why you would pick one versus the other. Now we'll look at if I wanted to open up soundcheck and start doing these things, how would I do them? The first question is, what is a sequence? So a sequence is a script to carry out an automated sequence of events. Sequences can be as simple or as complex as the user desires. I have seen 3-step sequences and I have seen hundreds and hundreds of step sequences. It's really what you're trying to do, what your goal is, how much of it you're trying to find out in one sequence. Do you want to write multiple? But it's just a way to actually test something in soundcheck. The sequence itself is comprised of a single SQC file, which contains all the parameters, settings, and logic for the test. This is separated from the hardware and calibration a little bit. Hardware and calibration is for your soundcheck installation. That's going to be applied to the sequence that you use. But I could then take this one sequence file, mail it over to one of my colleagues, they'll open it up on their machine, and it will use their hardware and calibration. One thing to note, though, is that you might have some dependent files, something like a wave file you're playing back, or recalling in C weighting on one of your tests. For that, there's an option to export out the sequence, and all dependent files will be carried along as well. So if you're trying to send a sequence to somebody else that's using dependent files, if you go into the File menu under Export, point to the sequence you're trying to export, and it will put the sequence plus all dependent files in its own directory. So what is a step? A step is a building block of a sequence. So a sequence really is just a group of steps. Each step is from a specific category and carries out a specific function. A stimulus is a type of step. Once I drop a stimulus step into my sequence, I could change it from white noise to log sweep, but without removing it or completely replacing it, I can't then change it to an analysis step. So these groups, once the step is into the sequence, I can change within that step type to whatever I want. But if I want to completely change the type of step, I would need to replace it. Steps are created from template files. When you first open soundcheck, you're going to see a bunch of step templates that are included. Once a step template, though, is inserted into a sequence, it will become part of the sequence file, and it's no longer tied to the original template. Using my previous example, if I dropped in a white noise template into my sequence, and then I said, oh, actually, I want to have a two-tone stimulus instead. If I changed that step to two-tone and saved the sequence, when I went back to my original template, it would still be white noise. Once it's dropped in the sequence, I can edit it however I want, and it does not affect the original template. But you can create as many templates as you want. I definitely recommend doing this. You can even delete templates that you're not interested in. There might be a ton of IEEE GPIB turntables message step templates, for example, and you don't have that turntable, you could go in and delete all of those step templates to kind of clear up your library. But then if you have an analysis step where you want every single thing to always be analyzed in this specific way, go into your editor, make the settings you want, then every step type will have a Save As button. When you click Save As, it's going to save out that step as a template. That template could then be dragged into sequences and used exactly the same as the one that you configured. You can store sequences anywhere. One really common use for this would be to put them on a network drive. Instead of me having to go out to 20 different machines and physically put a sequence on their desktop and have them run it, I could keep all of the sequences in one location accessible by every machine. If I ever needed to make a small change, I could go to that location, change it, then every person that accesses that sequence from the same location will be pulling down my new version. Sequences can also have dependent files. We talked about this a little bit earlier, but you might want to be recalling in data files or using a wave as a stimulus file, and that won't actually be included in the SQC file. You'd be pointing to something on disk and using that. When we first open Soundcheck and create a new sequence, the first thing we see is a completely blank sequence editor. You can see here it's broken up into two main parts. On the left is the step templates, and on the right are the sequence steps. The sequence editor on the left side, where the step templates are stored, is this library we've been talking about. All the templates are broken down by category. You can click the plus sign to open up the category and see every step type that's available in here. You could right-click and delete certain step templates. You could right-click to create new ones, rename them, move them around, and do whatever you want. You can even import from previous versions. If all of these step templates are actually files on disk that are saved in the Soundcheck directory. If you had a R&D system with a ton of templates that you loved and you're moving over to a new computer, you could just copy over that directory, right-click in this editor, and then import a full directory of step templates. On the right side is the currently loaded sequence. Before, it was blank except for that overall sequence parameter in the top. That overall sequence is a way we can configure the behavior of the sequence itself. If we double click on that step, we're actually going to see some behavior that will change how the step runs. We could set it to preload stimulus. We could change how the displays are cleared and repopulated, when data is deleted. And that's going to be a global setting for this sequence itself. The rest of the steps that are numbered, we can see the stimulus, for example, is step number 1. When we push start, it's going to start at step number 1 and move down one step at a time. It will happen sequentially. We can drag and drop from the left side of the step template library into our sequence to add in a step. Once it's in here, we could highlight and click it and drag and drop them to completely change the order. Since these run sequentially, it matters a lot which order we have these steps in. If I want to change where my post-processing step happens, I could click on it, drag it to a new location, then when I run the sequence, it will happen in the new order. Similar to double-clicking on overall sequence, each step also has some configuration we can change. If we right-click on a step, at the bottom there's an option to configure the step. We're not going to go over this too much, but this configuration is really powerful and I recommend looking into it. It'll allow jumping, branching, and looping. If I wanted to automate running my test 18 times to test a turntable in 180 degrees, I could right-click on these steps and say jump up to the beginning of the sequence, and then after n repetitions jump out of the loop and do something different. There's also a way to just quickly see what the step configurations are, as well as what data is going into or out of the step. On the left of all of these, there is a plus sign. It will show you what data is going in, what data is going out, and then if there's any looping or if there's any overwrite settings. This might not be extremely helpful for a simple sequence. You might be able to quickly see what's happening. But think about a sequence where you have 10 stimuli defined with 20 acquisition steps and then 50 analysis steps. If you're trying to remember, oh, well, which stimulus goes into acquisition 4, you could just click the plus sign, look at data in, and without having to go in and change the sequence around, you could just see what's getting input into the sequence and what the name of the response waveform is. How do we actually insert steps into soundcheck? From our step template, choose which one we want to start with. Remember, this can be modified for your use case later. So usually pick something that's close to what you're trying to do, either a template you've created before and you know that you want to use, or at least something from the step type that you're interested in. But we can again later modify it for your specific use case. Then drag the template into your sequence. Alternatively, from the right side of the sequence editor, we could right-click, insert, and choose template. That will bring up the same menu of step templates, and we would pick which one to add to our sequence. One convenient thing about this is we could also use this to replace current steps in a sequence. If I had an analysis step I no longer wanted to use, but I wanted an analysis step in the same place, I could right-click on the step and replace the step. That would leave the flow of my sequence the same. It would leave the step count the same, but it would simultaneously delete and add in a new step. This last part is optional, but recommended. The step template names are fairly generic that ship with soundcheck. When you add it to your sequence, we recommend to right-click on it and then select Rename. Change the template with something more specific to its function in the sequence you're actually using. Let's say I took in a post-processing curve average step, but I was actually using it to find the sensitivity of my frequency response. Instead of leaving the name as curve average, I would want to rename this and change it to sensitivity. That way, when I'm quickly trying to debug my sequence later, or I come back to it in 3 weeks and forgot what I was doing, without having to open up every step, I can say, oh, all right, step number 7 here, I called sensitivity, it's outputting sensitivity, I know what's going on. As your sequences get longer, this is something that's going to save you a lot of pain in the future. When we looked at our editor, there is the prefix to the left of the step name, and that is the category. If it's a stimulus step, it'll say STI. If it's an acquisition step, it'll say ACQ. And any type of category can be edited, do anything in that same category. So remember, any stimulus we can change into any stimulus. But if we wanted to change the complete category, we need to replace the step. You edit it, double click on the step in the sequence, or if you're trying to edit a template, double click on the template, and it's going to open up the step editor. From here, make any change that you want. Then when you click OK, that new step will be saved within the sequence. If we wanted to make whatever we just created a new template in the library, we would click the Save As button at the bottom. Then that template's going to be available to insert into any other sequence we wanted. When you're running a sequence, we can leave the step editor open, the sequence editor open, and there's some visual clues that will help us see what's going on in our sequence. For example, here we can see that the current step that's occurring is step 11. That is the current running step. We know that step 11 is going to happen, then step 12, etc. If we see soundcheck get stuck on a step or something seems to be not doing what you expect to do, just visually glancing as this yellow line is running through the step, we'll see what's kind of going on, might help you diagnose what's happening in your sequence. Some steps in soundcheck will pass or fail. Limit steps will always be defined with either an upper, lower, or both for what limit should the piece of data pass. If it's within it, it's going to pass. If it doesn't meet it, it will fail. As a quick glance at this, it's going to output all of those pieces of data to the memory list and give me a result. But in the sequence editor, I can quickly see that steps 6 and 10 failed because they're showing up as red, and steps 7 and 9 passed. So without needing to go into my memory list or opening up any data on displays, I could just run my sequence, then say, all right, well, now I need to go look at step 6 and see what happened, double click on that, start editing it, make sure it's configured the way I want, double check the data, etc. In the top left of Soundcheck is the toolbar. The Start button has 3 different modes. This is the green button all the way to the left. If you click it the way it looks right now, or press F2, it'll just run the sequence once. If you want to run the sequence continuously, you can press F3, or click on the caret to the right side of the play button, and in that drop-down, you'll be able to select Run Continuously. You can also redo the last sequence run by clicking F4 or choosing that in the drop-down. When you select this option, it will replace the statistics in autosave data of the last sequence you ran. When would you want to do this? So the case that I always think of is if you're running a test on a production line and you have statistics running to give an overall yield of the day. You get a speaker, put it up, push start, realize you forgot to plug it in. Everything in Soundcheck fails. It's not actually a fail, it's not a bad unit. You don't want your overall yield for the day to reflect that. So what you could do is plug it back in, then just push F4. It's going to throw away the last data. Everything that was saved, everything that was added to statistics will just get dumped out, and it's going to take that new sequence run and replace it. The Stop button will abort the current running sequence. That's the button in red. You can also click Escape. The Step button which is one to the right of the stop button, will advance to the next step from a breakpoint. This will be a single step. We'll look at breakpoints in a second, but let's say I stopped at step 12. If I wanted to run one step at a time, I could click the step button to just be running single steps. The continue button, all the way to the right, or you can access this by pushing enter. In the step configuration, I could set a step to wait for confirmation. That means it will wait until an operator either pushes enter or clicks this confirmation button. Or if we added in a breakpoint and we didn't want to just step through sequences one at a time, we could push continue to run through the rest of the sequence at once. So here are breakpoints. These are going to pause the sequence before a selected step. This really is used for troubleshooting and debugging. This isn't something that you'd want to usually have on a final running sequence. Why you would want to use this is, let's say in the sequence below, when I run my stimulus acquisition and analysis, I'm not getting the data I expect. But instead of running my full sequence, I'm trying to fix these top 3 steps to make sure they're doing what I want. I could add a breakpoint at step 4, so whenever I run the sequence, it'll just run the first 3 steps and then stop. Then if I ever got it working the way I wanted, I could use the continue or step button in the toolbar to continue on the rest of the sequence. Otherwise, I could just keep running the beginning portion of the step. These are indicated with a red dot. So if you look again at this picture, step 4 has a red dot on the left side of it. That means there's a breakpoint here. We add and remove breakpoints by right-clicking on the step. We can either add it or clear it. Another really helpful tool for troubleshooting or editing sequences is the Apply and Run from Here options. Instead of running a full sequence, we can apply single steps by right-clicking on them and selecting Apply, or opening up the step editor and selecting Apply. What I will usually do with this is if I have a step that I'm trying to set up the way I want, but I'm not quite sure what parameters I need. What if I'm trying to set up an estimated resonance post-processing step or configure an analysis step with some different distortion options? Instead of running through and acquiring new data through the acquisition step every single time and running the sequence, I could open up the analysis step after one run, make a bunch of changes directly in the step, and as I'm making the changes, just keep hitting the apply button and seeing what's different. If I just want to see what happens when I add in harmonic 12, I could just enable harmonic 12, click apply, see what the difference is. Run from Here is available in the sequence editor. Usually this in conjunction with breakpoints is very helpful for debugging something maybe in the middle of a sequence. It will run the step you have selected until the end of the sequence. But if you put in a breakpoint, it could be a really good way to try and figure out what's happening in a certain bunch of steps. For example, steps 60 through 70 seem to be doing something weird, but I don't want to run my test 1,000 times to run all of those sequences. I could drop a breakpoint at step 71, then right-click on step 60 and say Run from Here. It will apply step 60, jump down to the end of step 70, give me all the new data in the memory list. I could go make some changes, play around with some data that I think might be misbehaving, run it again. And then instead of having to completely run a full sequence or make a million changes, I can just really concentrate on the area that I'm trying to fix. Okay, so we have talked about how to take some different step types, when to use them in conjunction with another, and then how to kind of put them together in theory. Oops. What I want to do now, 1 second, there we go. What I want to do now is take what we were discussing and think about it from a specific use case. We have a device we're thinking about, something's actually in mind. Then how do we look at these tools? How do we put together a test to get the data we want back from them? So in this example test case, what do we know? I know that the device I'm trying to test is a loudspeaker. I'm working on a production line, so I don't have a lot of time. Speed is something that's very important to me. I'll also be testing in the near field, so I know the environment that I'll be in. Then what do we want to know? This might be something that my boss told me to look at, something that I'm just trying to figure out to make sure that it's within limits. But what I'm trying to do right now is get the frequency response in THD from 100 Hertz to 10 kilohertz, as well as looking at the polarity of the device. So what do I need in this use case? Well, I need to be able to have at least one input and output channel of an audio interface. I don't need an electrical measurement, I only need an acoustic. So for the input side, a calibrated reference microphone connected to some sort of input. Then on the output side, I need a calibrated amplifier. So my amplifier is calibrated, I know what voltage I'm setting to it. That voltage is going into my unknown device under test. That response is getting captured by my reference microphone. Then comparing the two, I can run it through an analysis step. So at my house right now, I have a setup that's exactly matching this. I have an audio connect with an SCM3 reference microphone on input 1. Then on output 1, I have a calibrated SCAMP amplifier connected to an unknown device. What are my next steps here? What am I trying to do? What should I do next? I want to jump back to the chart that we saw at the beginning. I know that I need to get frequency response and harmonic distortion. If I know this already, then I shouldn't spend a lot of time looking into an FFT spectrum analysis step, because that's not able to get me the data back that's required. I can simply say, okay, harmonic track and time selective response are the algorithms that will get me the data that I need. Once I have that, I usually like to go back to the other chart we looked at. So I could see harmonic track and time selective response here. I can confirm that both of them will get me the desired measurements out, and I could see what applications are common with them. For this use case, I could definitely pick either one. I could get usable data with both. But I'm going to say I wanted to use a step sign sweep stimulus, and since I wanted to do that, I can't use the TSR algorithm. Both of them would have been fine, but now it's just down to my personal preference. So, what do I know and what do I need to do now? I'm going to use step sign sweep with harmonic track. So in sound check, I'm going to add in a bunch of steps. So I'm going to take templates that are close to what I want. Then once they're added in, I'm going to edit them for my specific use case. One other thing I'm going to add at the end is a display step. A display step can be configured to show data as sequence runs. And I want to, at the end of the day, be able to see my fundamental in THD. And especially as I'm writing a sequence, I like to put in a display step just so I can see what happens as I'm making changes to my sequence. So now I jump over to soundcheck. All I'm seeing open is my memory list. What I want to do now is open up a new sequence. I can click on File and select New, or push Control N. Once this is opened up, I have my sequence editor. We can use the templates and just start writing the sequence, but the first thing that I actually like to do is just save the sequence out as something else or rename it. Right now, the name of my sequence is new sequence. That's not particularly helpful. If I save this and then come back to it later, not really what I call descriptive. So if you go to File, I can select the Rename option, or I could click Save As and put it in a specific directory. So I'm in Save As right now, and what I could do, and usually what I like to do, is create a new folder in the Sequences directory, or somewhere on storage that allows me to access it from different areas. But right now, I'm just going to save it locally, and I'll give this a new project name. Inside this new folder, I usually like to just give my sequence a name that has some sort of clue to what we're doing. So now when I open this, I can say it's a fundamental in THD for speaker and project XYZ. I'd also recommend either dropping in a version number, maybe putting in the date right in the file name. So we could save this. Maybe when I open it up tomorrow, I'll save it with the new name, with the new date, call it version 2. But what I really want to avoid is building up a sequence over a couple days or a couple of weeks, then making one sweeping change to it, realizing I hate the change, but I already saved it, and then having to go dig myself out of the hole. So if we make some different copies of it, it's easy to go back to a working sequence in case anything happens that you realize later was a mistake. So now I have my new sequence name, fundamental and THD speaker, with the date. And I usually just like to save the sequences as well. So I have a fresh slate ready to go. Let's start dropping in steps. The first thing I'll do is add in my stimulus. Here we have Sweet 10K to 100 Hertz R40. This is pretty close to what I want to use. That's a good starting point, so I'll drop it in. Right when I add it to my sequence, it's going to ask me what my output signal path is. I have amp channel 1 calibrated, ready to use for this test, so I'll select that. Next, I want my acquisition step. I could do the same thing by dragging it in, but another way to add it is just to right-click in here and select Insert Step. When I choose a group from over here, this is going to be the exact same as the options from looking in the drop-downs. So I'll say play and record. It's going to ask me what input signal path I want. I want to use my reference mic input, and my amp channel 1 output. Remember that the stimulus step is defining the waveform we're using, but the acquisition is what it's actually getting output out of. So I could have my stimulus defined by a completely different channel than my acquisition. This might make sense for, let's say, a stereo recording. If I wanted to play out of amp channel 1 and 2, I could open this up, highlight both amp channels by Control or Shift clicking, and with both of them, use the stimulus that was defined for amp channel 1. These are going to be pretty close to each other. The amplifier might be the same exact thing, so I can just define the stimulus once, then output it twice. But what you do want to be careful of is I don't want to then play this out of direct out 1, because the voltage that I defined in the stimulus step won't match up with the actual voltage out of a completely different signal path. It's pretty easy to check that. When we're in the sequence, the out and in sides will show us the calibrated signal paths that we're using. If I run the sequence now, I'm going to output my stimulus and record it in. Get some amount of data. What I'm actually interested in now is to analyze it. The next step I'm going to drop in is this THD template. I'll put this here at the end. When we open up the memory list, I'll start seeing what's getting generated by these different steps, and we can kind of follow along with what's happening. If we use these plus signs over here, I can see that this sweep is outputting a value called sweep, which is this waveform over here. Acquisition is taking that stimulus as an input, and then for output, giving us that max FSD in value, which we talked about will help us get some better signal to noise ratios, then outputting the recorded time waveform. Then finally, the analysis step is inputting the sweep and recorded time waveform, comparing the two, and giving us a fundamental, some harmonics, and THD. So this is close to what I want. I'm pretty happy with it. As a quick shortcut, I could right-click here and select Collapse All because I don't want to see all of these expanded. I just want my 3 steps, and start the sequence. All right, I got data, but where is it? It's in the memory list, not actually shown to me. So what I want to do last is drop in a display step. I'm just going to pick display default and put it at the end. To edit this display, just like editing other steps, I double click on it. It opens up the current display, and I can control click some different values, drop them on this graph, and see what I got out of my analysis. I can see here my fundamental in blue, and then another line in orange. I'm not quite sure what this is, so what I'm going to do is right-click here and select Auto Size Legend. I just want to make sure that every time I add a new curve to this graph, it actually will update, and I can see what the new name of that curve is. So here, yep, it's confirmed my orange curve is my THD. This is what I expect. I'm happy. So with just these 4 steps, my sequence does something. It gets out what I want it to do because I kind of planned ahead to make sure that all of these fit together to get the data out. But there's still work to be done here. This isn't ready to ship. It's very basic. So what can I do with it now? So one of the first things I'm going to do is look at how long it takes to run this. I know I'm testing this on the production line, so time becomes a really big factor. If I look up here in the top of soundcheck, I can see that there's a value to the right of the speaker, the sequence name, that's showing me 2.8 seconds. This value is the length of time it took to run the last sequence. So my sequence takes 2.8 seconds. That's too long for me. My goal is to get it under 1 second. I want it to be much faster. So how do I figure out where to make the sequence quicker? So this value is showing me the full sequence, but one thing that can be really helpful is in the Edit Preferences menu, under the Advanced tab, I can enable this log sequence duration and memory usage field. Instead of just showing me how long the most recent sequence ran, I can actually open up, let's move this over here, and in my Soundcheck 18 folder, where I'm running the sequence, it's going to create a new file called timememlog.txt. If I open this, I'll see how long my sequence took to run. What I'm interested in is the one right here from 3:44 p.m. I can see my sequence took 2.8 seconds. That makes sense. That's what I'm seeing up here. And then it's going to show me how much memory was used. But what I'm really interested in is the next pieces of data. This is showing me which steps ran and how long each of those steps took. But right now, I'm only seeing 3 steps, even though my sequence ran with 4 steps. So what's happening here? This goes back to something I mentioned a little bit earlier offhand, but it's a feature of Soundcheck called Preload Stimulus. We can enable this by double-clicking on Overall Sequence, and it's this first section here. When sequence opens, preload stimulus. What this will do is look at the stimulus step, see what parameters are available for it, then right when the sequence opens, just make that a waveform in memory. Now, when the sequence runs every single time, I don't need to spend resources creating that stimulus because that waveform already exists. It's recommended to leave this on because that means I'm now saving a full step from running. My stimulus step doesn't occur. But again, the trade-off is if I'm ever using memoryless values in my stimulus, I'll need to turn this off because my sequence will need to be running to have the values available to create my stimulus. But that's not the case for me, so I'll turn it on. Now I go back to the chart and I very clearly see that the cause of most of this slowdown, or the length of this sequence we're running, is this 2.787 second step, which is my acquisition. So what's going to cause this acquisition to take so long is how long it needs to play out my stimulus. Most sequences, the bulk time taken is in the acquisition step. If I need to shorten my sequence, I'm going to try and approach it by shortening my stimulus. That's going to usually get me the most bang for my buck. So what could I do here? My resolution's R40. I don't need that high of resolution. third octave is fine for me. And when I make this change, notice that the full duration of the stimulus, which is shown in the bottom left, as well as the graph, hasn't changed at all. To see any changes I make within the stimulus editor, I need to click this Update button. So now it shows me that the duration is 646 milliseconds, which is much shorter. You don't need to click this Update button for it to change the stimulus. If I ran my sequence, you're going to be okay. But if you're trying to make changes and you want to see what's happening, you do need to click the Update button. Okay, so this is pretty short, but not short enough for me. The resolution is how many steps there are. By setting it to third octave, I'm defining 21 steps. But I can also change the step size. So if I'm specifying 12 cycles as the minimum cycles, and then 10 milliseconds as the minimum duration, what that means is that at every step, it's going to satisfy either the minimum cycles or minimum duration, whichever is longer. So if we picked a random point, let's say 10 kilohertz, it would say is 12 cycles longer at 10 kilohertz or is 10 milliseconds longer. At the higher frequency points, the duration is going to be longer. So at 10K, it's going to play for 10 milliseconds. But down when we get to the low frequencies, say 100 hertz, 12 cycles is going to take longer than 10 milliseconds, so it will play for 12 cycles. I want to be as quick as possible. If I select 1 here and 0 here, that means that I'm just going to play 1 cycle at every step, and my stimulus is now 58 milliseconds long. So great. Run my sequence, and I can see this sequence took almost no time. I cut it down to almost nothing. But the question usually is that worth it? There's a couple tools we have that we can try and see how much we're losing by reducing the length of the stimulus. In Harmonic Track, under the Distortion tab, you can see this option for confidence limits, plus or minus n standard error. If I enable this, it's going to show me in the memory list how confident it is by comparing the noise that's being measured versus the signal. And maybe I don't need to be within plus or minus 3. Maybe for this test, I'll say plus or minus 2 is fine. So I click OK, and you'll see a bunch of new curves got added to the memory list. What I'm going to concentrate now is just removing the THD, and I want to look at the upper and lower confidence limits of the fundamental. I drag those on the graph, but there's no actual data here because the step didn't run yet. So I don't need to run the full sequence. All I want to do is change this step. The waveforms already exist, so I could just right-click and select Apply here. And here are the upper and lower confidence limits. You can see this blue line at the top is almost lost in the orange. We can't really see it because the scale of this graph is minus 1,000. Soundchecks is saying basically there's so much noise, especially at the upper frequencies. I'm really not confident at all in my measurements. I could right-click on this graph, turn off auto scale, then I'll manually type in, say, 60 dB, and I can see what this graph looks like. So there's a wide range here of what Soundcheck is actually calculating. It's estimating what the level is, but with such a short stimulus, it's really not that confident. So maybe if that's the case, I'll say, okay, fine, you can have a little bit more time. We'll go from 58 milliseconds up to 3 cycles. Now we're at 154 milliseconds. Run the test again, and they're getting a lot closer. Every time we increase the cycles, we're basically adding on 50 or so milliseconds. But the nice thing about this step is I could define just the minimum duration as well. So let's say if I had 5 milliseconds, that's increasing everything above 600 hertz, because everything above 600 hertz, 5 milliseconds is longer than 3 cycles. That's showing us here in the transition time. And when I run this test now, you can see around 500 hertz, those two lines are converging very closely. So that's telling me that 5 milliseconds might be a good minimum cycles for this, but maybe, or minimum time for this, sorry, but maybe I still need to increase my cycles. And kind of this play between how much time is my sequence taking. If I run it now, I'm still at under 1 second at 700 milliseconds, so maybe I have more time to increase cycles. This just gives me some options to see what I can do to get the best type of measurement without spending a lot of time. So as you're trying to develop a test, especially one where time really matters, take a look at the confidence limits, see what you can gain by increasing different parts of the stimulus step. What I want to look at next is the max FSD in. What I care about is this Y value here. So I know that this Y value should be between, say, minus 30 and 0. Right now it's at minus 50. There's a couple of things I could do here. Right now my device is very close to the speaker. It's about an inch away, and I might not have the option to move that. But I could increase the level. When I dropped this in, this was just a generic 100 millivolts. Maybe I want 300. Run the test. Okay, we're up to minus 42. That's slightly better, but not quite there. What I want to try is adding input gain to my Audio Connect. If I read my Audio Connect configuration right now, I can see that the gain is set to 0 dB. I could just turn on 20 dB on the front panel of it right now and see what changes. But what I want to do is under acquisition, I'm going to set the gain from auto read to auto range. When the test runs, it will calculate the FSD. Audio Connect has an option of 0 or plus 20 dB gain. If the 0 option isn't within that range, it's going to try and apply that gain to get within it. I don't know how much you can hear my sweep run, but when I push go in the sequence, it's going to run the test once, adjust the gain, run it again. Now I'm up to minus 22. Great, that's within the range. I'm happy. So a lot of the major things I was trying to do here are done. The last thing I was interested in was the polarity. In the analysis, there's a checkbox here under delay when using auto delay to just give us a simple polarity check. Anything with auto delay is going to have this option as long as it's comparing an input versus an output. So if I click OK here, under values, I see polarity. And what this will show me is if Y is positive, it's positive polarity, and if negative, it's negative. So Y equals 1, I could set a limit on this eventually and show myself a nice green pass as long as this isn't a negative number. My sequence is in a position that I like now. I'm again just going to make sure to save it. And what other steps are available for me to take? What else can I do to improve this? So, more steps. Adding in post-processing, putting in limits, making the displays better. No one is very interested in seeing the FSD in the display of a sequence that runs. That's helpful for troubleshooting. But when I go back and actually edit the sequence, I'm going to remove it. Notate your sequence. My first step is actually mislabeled now. It's called R40, but I changed it to R10. If someone comes in to run my sequence and sees R40 as a stimulus type, they might assume it's R40, because why wouldn't they? Go back in, change the names of your steps, change the names of your waveforms, add in sequence comments, add in comment steps, add in comment lines. Give yourself a fighting chance when you come back to things from a week ago. Don't tell yourself, oh, I'll remember, because I've been there and I don't remember ever. So I definitely recommend to put in as many notes as you can about what you were trying to do, what you did, what your steps do. Back up your sequences. Keep a revision history. Make sure that you have something to go back to if something gets broken for the day. This was a very simple setup. It's not a lot of things that changed. But if I go in and I was using external hardware and TCP/IP control and talking to a turntable, one thing that I will even do just to make sure that things are good is just save my entire soundcheck folder out into a new directory, make a copy of it, send it to a compressed file and back it up. And if anything happens, if anything changes you weren't expecting, just restore your entire directory and start working. It's going to save a headache of trying to rebuild a broken sequence because something was changed and you don't know what it was. So back everything up. We talked about logging sequence duration and memory usage and preload stimulus. And with that, thanks for joining. We really appreciate it. What I recommend is, again, try and use soundcheck. Maybe try some of these tips. If this is fresh in your head, maybe try and explore something. Take a look at some of the notes we have. Get back to us. If you go to listeninc.com, we have a lot of resources available. Under support, we have soundcheck tutorials, knowledge-based articles with a lot of frequently asked questions. And if anything comes up on these tickets, if anything that you're looking at didn't make sense or you want a clarification or just got a new idea and you want to run it by us for some best practices of a specific use case, give us an email. Let us know at support@listeninc.com. Give us a call. We want to hear from you, and we really appreciate your time.